Okay, so now that we've got this figured out and wired in, it's time to check voltages. 12.1. A little adjustment screw here. Just dial it just ever so slightly counterclockwise. $212 dead. Take those off. Turn that off. Wait for the light to go out. We repeat the same process on our 5-volt supply after we wire it in here. After that's done, it's time to splice the crydom in to one of these. One line goes to the crydom, and then from the crydom to the line. The other one goes directly to the neutral. This little black wire set, I'm actually going to run along with everything else over here. And those are going to hook into the ground. Let's grab the bed just in case the bed heater ever gets a nick or a cut or there's a manufacturing defect. We don't want the bed or the rest of the machine becoming electrified. We are working with 120 volts here. It is dangerous. If you're working in a country that runs on 220, it's still dangerous. It's not fun. So let's try to minimize any issues doing that. That's why you also want to make sure that's dead. And then before we do anything, even though we've turned it off, unplug it. Don't play with power when it's plugged in. Unplug it. Don't get zapped. Be careful. I'm going to get these two wired in, check this out, and then we'll come back. Alright, we've got the relay wired in. Got a line coming from the line into one side, out the other. Neutral comes directly from the board. The grounds come directly from the bed. Next thing I think I want to tackle, I've got a new bracket for this printing, that's what that noise is. Next thing I want to tackle is the power connection coming from the little 5-volt converter to the Pi. So I'm going to take some of our leftover wire here. I'm going to pull off a fair bit of it. Because I'm going to try to cable manage this all in. And cut off another one of these. I'm going to put a spade connector on one end. I'm going to put a DuPont on the other. Putting DuPont on is the same as everything else we've done. Strip it, crimp it, put it in. I'll come back when that's all wired up. Actually, you know what? I'm going to show you how to do the DuPonts. Just because. I'll show you how to do one of everything we do on this rig. You want, again, a very small, like 2 mil section wire. Little DuPont connector. Our connector pliers, again. I believe the DuPonts use the 1.4. Yeah, the DuPonts use the 1.4 instead of the 1.6s like the Molex and JSTs. But they go in the exact same way. You get your little bit of wire in the far set, and the set closest to the opening. The insulation goes in the near set. Crimp it down, pull it out, to get the crimp ends for the insulation in. Give that a nice crimp. And then I believe we want to use the 3-pin for this one. Basically, we just push the end in as far as it'll go. Oh, I got it. That's that end done. Crimped end. Really was hoping we had some narrow spade tables. It says it's massive. But we don't. It's not in that box. Let me see if I can find my other box. Okay, so we may have some narrow ones that fit, and we do. So the thing here is, we've got 2 of these little spade terminals. Crimp on just like the normal terminals. For these you need about 4 to 5 mil. Stick the wire through. Line the crimp up. Squish. Give it a little tug test. Make sure that it stays. With that done, I'll do the other ones. I'll get this mounted and I'll come back. Okay, so I've got the power for the Raspberry Pi coming up through and is mounted over onto this block. Again, this is getting reprinted. And just because I want to get it out of the way, I'm going to mount this temp, or almost temp. So the first thing we got to do is we got to get this unfolded. Take 2 of these T-nuts. And 2 M3x8s. Let's start with 1. I'm going to drive it down through the hole here. Cinch this thing down and fold it back up. So that is this guy out of the way. Next big thing, I think, is to do the power lines to the two SKRs. That won't be too bad. It's really all we gotta do. So a couple lines from here, over to here, and over to here. We are gonna go two different directions. Just because it'll be a little easier to run wires two different ways. So we use our standard technique from everything else so far. Go over here. Hold out where we want it to go. And snip them off. Repeat for the second set. And then for these ones, in addition to getting spade terminals, or fork terminals that go over onto the plus and the minus, they're going to get these crimp-on ferrules, which are these. I'll show you how we put one of them on. That's where these strippers are nice, is they've got a fence. So if you need a certain amount of wire after a certain length, because the fence only goes so short. They're quite handy. So for these, what you do, strip off the wire here. And my crimpers. These are nice Iwis crimpers, designed specifically for these little ferrules here. I actually think that ferrule blacks are too big. Let's go with a red and see if that's the right size. I want it to be almost a snug fit. Reds might be a little too big. Let's try whites. Okay, I like how the whites fit on this wire. Mount it up. Hold it in. Run the crimp down. It's It's nice and secure now, not coming off. And this is actually the proper way to do this type of crimp. From here, actually back this screw out. We snake that in. And that is the proper way to terminate a screw down connector. I'm going to get all these done up and 4 terminals put on these, and then we'll come back and start doing all of the JSTs for the beds, or for the motors, for the end stops, the sensors, the thermistors, all that fun stuff. Okay, a couple of things. In the manual, page 117 has your SKR wiring. Or not your SKR, your SSR wiring. As does page 120. Page 117 has the correct wiring for pins 3 and 4, as you're putting the positive on pin 3. Like so. And the negative on pin 4, like so. It is incorrect on the wiring for the SKR board. Page 120 has the correct wiring for the SKR board. Keep that in mind when building your JST connector for that. The next thing, the pinout for these 2 connectors, as I mentioned when we mounted the display in the housing, is backwards. On the standard housings, or the standard displays, the little key relief and the connector housing is pointed towards the bottom. We need to flip them 180 for mounting with the SKRs. Since I've just removed the connector housings and I don't know where I put them, I'm just going to flip the cables themselves over, which is a perfectly valid thing to do. So the key on the cable will be facing what will be the top of the machine. It will be facing the board. And this one goes into EXP2. And this one goes into EXP1. And then it will get brought over here and zip tied down so that we have full range of display motion when we get to that point. The only thing really that mounts on this board, other than the Z end stop and the nozzle probe, is, for the moment I will say, is the temperature sensor for the heat bed. We will mount the controller fans and the exhaust fan to these, but I don't have the housing, and I don't have the fans, and I don't have the side skirt yet. So those I'm going to leave off for the moment. I will put those into the final update video for this thing, or the final assembly video. Post-PIF assembly video. I'm not sure what I'm going to call it yet, but that's what's going to go in there. So those get left open. If you guys have the side skirts and you're mounting the controller cooling fans, they go in this one. If you have the exhaust duct, it goes in this one. Really quite straightforward. We will have to make up the little extension cable that goes from here over to here where the probe comes in. And then we're going to have to run the brown wire from the probe to B+, the blue wire, which is the signal, to one of these pins, and the ground wire, which is the black, to the other of these pins. I will roll in a screenshot from the manual for how that goes. But that will be done off camera. Now, the other thing is there is a diode. Pay attention to the direction of the band on the diode. We need to use that to drop the signal so that it doesn't blow up the boards because we are powering the sensor off of 24 volts. Just keep that in mind. So I'm going to do the bed and the Z probe for here. And then probably going to do the X and Y for here. And then start running in the motors. We got the X, we got the Y, we got the E, the A, the B. I believe that's A and B. Plus we've got the hot end. I want to say this one's the hot end fan, that one's the part fan. I don't know what that one is off the top of my head. Plus the A, the A, the B, the E, X, Y, thermistor. Yeah, we got some wires to take care of here, but that's okay. We'll get them all. I will do them all off camera because it's all going to be the same as what I've already done. You've seen me put on a JST. You've seen me put on the Molex. I might do a little soldering video for making the cable itself for the sensor. But I might show you how to put the diode in. We'll go with that. Other than that, there isn't a whole lot left to do in terms of wiring. It's just put connector on, plug pins in, call it a day. I probably will end up swapping these two USBs out for ones with right angle connectors, just so there isn't as much strain on the connector on the board. And then once we get the wiring done, we will have to do the clipper configuration for the Pi. The nice thing with this is you can take the Pi back off again without too much issue. So next time you'll see me will probably be a finished wiring and then into the Pi. So, see you in a bit. Alright, so I am putting on the Hall effect end stop wiring, and it's not very clear on how you do this. But what you end up doing is you take the 5 volt and the ground from the board, and one of the two signals, I don't care, it doesn't matter which one, in this case I'm using the X, they're all going into the X pin. And then the Y gets its own, and goes into the Y. So you take your 5 volt, because that's the one closest to the housing, the ground, so that's the one in the middle, and the signal, all wedged in, of course. These connectors take a little bit of fiddling. Loop your wires into place here. In my case, plug in your X. And you take your Y, put its sole wire in. Finagle that wire into place. plug that in. So that's kind of universal. Ooh. So it's kind of universal. You got your power, your ground, your signal for your X go into one, and your signal for your Y go into the other. Not a whole lot to it, but they don't run through this in the manual. So if you're doing the Hall effect board, that's what your end stops are going to look like. Nothing to it, really. We will proceed from here. Alrighty, we are down to the last 4 plugs. And they're for the motors. Now, there is a specific order for these motors going into this SKR. This is also known as MCUZ, because all it does is control the Z's. This is the MCU, this is the MCUZ, and the instructions. Now, starting at the front, we're looking at the front. If you've got this thing the right way up, and your control panel is facing you, this is Z0, Z1, Z2, and Z3. On the board here, this is Z0, Z1, Z2, and Z3. So it's time for 4 more of the JST connectors. And the way that I'm routing these wires is, I won't say unique, but it is what I hope will be the easiest to cable manage at the end. So Z1, 0, and 3 come up this way, across the front, and down. Z2 is just going to come up this way. It's going to be a little awkward, but it won't be too bad. So let's get these wired in, and I'll give you a tour of the wiring. And then I think it'll be on to programming, or setting up the Raspberry Pi and the firmware on the SKRs. So let's get to it. I'll come back when they're wired up and we'll go for a tour. Last thing to do. I know I keep saying that, but this one I really think is the last one for the bed, or for the wiring. I've got 3 wires here. I've got this little red one. That's for probe power. I've got this little blue one. That's for probe ground. I've got this black one. That's for probe signal. I also have this little teensy tiny diode. It is a BAT85 Sierra. It's a 30 volt Schottky diode. And I don't know if you can see it, I hope you can, but there's a little black band on one side. It happens to be on the side with the little gray tape. This little side of the band needs to point towards the sensor. The side without the band needs to plug into the board. So what I'm going to do is I'm going to chop this right about here. I'm going to strip back a fair bit, probably. $10 to 12 mil on this piece of wire. And we're going to do the same on the other side. And I don't have a third hand. So this may be a little tricky. I'm going to trim off. That's my noopsie there. One of the tails here. We're going to attempt to do a proper, or a semi-proper alignment splice here. And we're going to fail. Slightly. So we're going to do a not quite proper alignment splice. Traditional alignment splice, you take both ends of the wires, you bend them about 90, cross them, and then you wrap the wires around each other in such a way that they, when tension is applied, won't come undone. A little tricky with stranded wire like this, so it didn't quite work. And then we are going to heat shrink this too, just because. We don't want any exposed high voltage. We have a metal frame printer and we have lots of stuff underneath that is sensitive to electricity, so whenever you're doing something like this, I'll take a nice big piece of heat shrink. It's going to cover the tails quite well. This is also marine heat shrink, so it has a sealer in it. Not that that's crucial for this application, but it is kind of handy. Common mistake that I make, and a lot of people do, is to wave the heat shrink directly in the fire. That will work, but it's not actually ideal, because you can end up burning the heat shrink. So what you want is to just wave it near the flames. As much as possible. And that is done. Now the black end was on the long tail. Trim that way too long. This goes into the signal pin, as mentioned before. We'll take the blue and we'll get it put in, and then we'll measure out the equal length. We'll put the 3-pin on this one end, add a spade on this end, get it wired in, and then we'll do a tour of the wiring. Okay, time for a tour of the wiring. AC power comes in here, goes through this cord over to these 3 terminals. From here they break out to the 5-volt supply and to the bed. One goes into the CRI-DOM relay, depending on who you're using. Follows the lines, comes back over here, and goes up to the bed. The other one comes back out, and it ties into the neutral. I've got the line going into the relay, neutral, from the bed. I've got 5 volts coming off of this, looping around, and going into a header direct for the Pi. There is a risk running it off of the header like that. It's not too bad, especially because there's some good overvoltage protection in there, and there's really no way we're going to pull more than the designated 3 amps out of that thing, or for this thing. I've got the 2 USBs running into MCU Z and the MCU. Into the Z, I've got the ground and signal for the probe. I've also got the nozzle plugged in and the bed thermistor. I also have power and the bed SSR controls, which runs over this way, up, and plugs into the SSR. Pin 3 on the SSR is positive, pin 4 is negative. When you're looking at it like this, the left pin is negative, the right pin is positive. No big deal there. This header, I believe, is the controller fans, and that one is the exhaust fan. I don't have either because I don't have the skirts or the exhaust done yet. But if you didn't get a printed forward kit, you can populate those. If you did get a printed forward kit, or you printed off enough parts like I did, that would be a printed forward kit. Those will be empty until we finish assembly after we get this up and running and can print off the skirts and the exhaust. These 4 are from nearest to us to the front, are for Z0, Z1, Z2, and Z3. Again, Z0, Z1, Z2, Z3. Moving into the second microcontroller, I've got the E drive, the A drive, the B drive. I have the part fan, the hot end, the hot end fan, and power. Power for this one comes along this side. Power for this one came along this way. In addition, I've also got the hot end thermistor, the X, and the Y end stops. This one is populated with all three because, again, that is how the Hall effect end stop works. Plug power, plug ground, plug signal in on one, plug signal in on the other. Off of the Z MCU, we also run the cables for the front panel display. Front panel display, if you're using the Feistek Mini, you need to pull the headers off and rotate the cables 180 degrees in order to run correctly. Shouldn't be too big a deal. That will be taken care of in clipper configuration as well, which I think is our next stop. So I'm going to pull the Pi so we can get clipper installed, Octoprint and clipper installed, and I'm going to pull the SD cards from these two boards so we can put the clipper firmware on them. We'll switch over to the computer in the next video and we will do that. So see you in the next video.
Thank you all for watching. I hope you enjoyed. If you did, please hit the like and subscribe buttons. It really helps me out and it lets you know when I put something new up. New videos will be going up on Tuesdays or Thursdays at 8 a.m. Eastern. And if I do decide to do live streams, I will try to give 24 hours notice. So hit the subscribe button on the channel and you'll be notified when I post that stuff too. Hope to see you next time. Sharps out.